Hi everyone. Now we are going to discuss about effect of dielectric in a capacitor. When we are making a capacitor, we have one equation. The capacitance of the capacitor is equal to A epsilon 0 by D. So we are going to make a capacitor of capacitance 1 farad. Distance between the plate is 1 centimeter. So from this equation we can make an equation for area of that capacitor. What will be the area of that capacitor? Equation is A is equal to CD by epsilon 0. So we are giving that values. C is equal to 1, D is equal to 1 centimeter. In meter it will be 1 into 10 raised to minus 2 meter, and the value of epsilon 0 is 8.85 into 10 raised to minus 12. So if we are substituting all this value, the area is approximately 10 raised to 9 meter square. It's too big. So for making a capacitor of capacitance 1 farad, it's not practical. That is the importance of dielectric. When we are placing a dielectric, according to the property of dielectric, we can increase the capacitance. So we are using dielectric to increase the capacitance. So we are considering which is having two parallel plate. Of this conductor is A, distance between this plate is D, and this is the dielectric, and there is an electric field from positive to negative. We know that the capacitance of this capacitor, if there is no electric field, is C1 equal to A epsilon 0 upon D. If there is no dielectric, this is the value of capacitance. It is a dielectric. This charge is plus Q and this charge is minus Q. And because of this external electric field, because of this external electric field, there is an external electric field. Because of this field, there will be polarization inside the dielectric, and because of the polarization, there will be an internal electric field EP polarization. This EO and EP are in opposite direction. So they are not going to cancel because this EP is very small, but the value of the internal electric field E in, it will be reduced because of this external electric field. So value of internal electric field inside this dielectric will be EO minus EP, because these two electric fields are in opposite direction. E in is acting the region of T. T is the thickness of dielectric. So the value of E in, the electric field E in acting in the region of T inside the dielectric, and E, now this electric field is acting the region of these two region, not in this region. So it is D minus T. And the electric potential, there is an equation for electric potential. Electric potential is V equal to E into D, electric field into distance. And here we need to add the electric potential in dielectric and electric potential in this region because of this parallel plate. So first V is equal to EO into, instead of D, we can, this EO is acting this region except T, so it is D minus T plus E in T. T is the thickness of this dielectric. Then VE we know that the external electric field, if we are increasing the external electric field, there will be increase in internal electric field also, because this polarization depends on the external electric field. This polarization internal electric field depends on the external electric field. We can write EO proportional to E in. To remove this proportionality sign, to change this proportionality sign, we can add a constant. That constant is K, dielectric constant. So EO equal to K into E in. K is a dielectric constant. From this equation, what is the equation for E in? E in equal to EO by K. Now we have the equation for internal electric field. Internal electric field E in is equal to E naught EO upon K, EO by K. So equation for potential, electric potential, EO into D minus T plus E in into D. We are going to replace this value of E in using that expression. So it will be using this expression. So V is equal to EO into D minus T plus EO by K into T. This EO is common here, so we can take it out. This EO is common, so equation will be V is equal to EO into D minus T. Here we are taking this EO outside, D minus T plus here also we are taking EO outside. So now what is the equation for EO, external electric field because of parallel plate? It is sigma upon epsilon 0. So we are substituting this value here. So V is equal to sigma upon epsilon 0 into D minus T plus T by K. Sigma is surface charge density, so equation is Q upon A. So we are substituting that value here. So it will be V is equal to Q by A epsilon 0 into D minus T plus T by K. What is the equation for capacitance? C. Capacitance of new capacitor which is having electric field. Equation is same, Q by V, and C is equal to, we are using this equation. Instead of this V, we can use this equation. So it will be C equal to Q upon all divided by Q A epsilon 0 into D minus T plus T by K. This Q and this Q will cancel each other, and equation will be C equal to A epsilon 0 all divided by D minus T plus T by K. So this is the last equation. Now we are taking this D outside, this D. So it will be C equal to A epsilon 0 upon D into, if you are taking D outside from here, it will be 1 minus, if you are taking D outside from D, it will be T by D, plus if you are taking T outside from T by K, it will be T by KD. So equation is C equal to A epsilon 0 all divided by D into 1 minus T by D plus TK. And this A epsilon 0 by D is C1. The A epsilon 0 by D means it is C1. Already mentioned in the first steps of this derivation, A epsilon 0 by D we taken as C1, then it will be C1 upon 1 minus T by D plus T by KD. If this denominator is very small, the value of capacitance will be increasing. It will be very big.